mathematicians, one of the most common and useful polynomials is a quadratic. Now, it's a special type of polynomial which has a power of 2. So the highest power is a power of 2. Let's look at some examples. For example, 4x squared plus 3x minus 6. That's a quadratic because the highest power is a 2, x squared. Here's another example, x squared plus 7x plus 10. That's a quadratic. Quadratics are super useful, and we find them and we can use them to model lots of things in the real world. We'll get to that actually later this year to see all those uses. The name quadratic, just interestingly enough, it means square, and it's derived from a Latin word that means square. All right, so let's just define what does it mean to be a quadratic. So a quadratic is going to have the generalized form of ax squared plus bx plus c. And this is telling us that we're going to have some number times a variable being squared plus some number times a variable to the first power plus some number or constant. We have names for each of these three terms. Notice this one is a trinomial. We say this first one is the squared term because it has the variable being squared. The second term, we either call that the linear term because the power of 1 means linear line, a linear term, or sometimes we just call it the middle term because it's in the middle. So that's the linear or middle term. And then finally, we have at the end our constant. Whenever we see general versions like this, it's always good to think, are there any restrictions on A, B, and C? For example, can A, B, and C be positive numbers? Yep. Can they be negative numbers? Yep. Can they be 0? 0 is always a good one to think about. So let's think about C. Is it okay for C to be 0? Absolutely. If C is 0, we're going to get something like 3x squared plus 4x. There's just no constant. Totally fine. It's still a quadratic. We have the highest power of 2. What about B? Can B be 0? Absolutely. And it's going to look something like this, maybe negative 4x squared minus 6. There's just no middle term, but it's absolutely fine because it's still a quadratic. It still has a variable being squared. All right, let's think about A. Is it okay for A to be 0? No, because look what happens. If A is 0, then we're going to get something like 3x minus 4. If A is 0, we have no squared term, so it's no longer a quadratic. This is now a linear. So we do have one restriction here, and that is A cannot be equal to 0. Now, the goal of this lesson and the next lesson is going to be how can we factor quadratics? All right, let's get on to it.